Hello everyone, welcome back to my channel again. For our last discussion, we discussed correlation analysis in SPSS, and in this video we are going to discuss multiple regression in SPSS for research. So this one is basically for researchers, so anyone can try it. And then we are using data from restaurants, so we use the restaurant data as an example. I will leave the data in the description section. So for this particular video, we are going to just explain the concept. This is my name, and then you can reach out to me in case you want to find out something or you want us to discuss something here. Now, what is multiple linear regression, or what is regression? Regression is nothing than to determine the influence of an independent variable to the dependent variable. So we have two main variables in it. We have independent variable that we use to test their influence to the dependent variable. So, and in regression we have two main regressions. We have simple linear regression, and we also have multiple linear regression. In this particular video we are emphasizing on the multiple linear regression, but we have to explain what simple linear regression is about. Simple linear regression is just using one independent variable to predict the dependent variable. So, and the multiple linear regression is just an extension of the simple linear regression. That is to say, we add more than one predictor. So the regression model for the multiple linear regression is beta naught plus beta 1 x1 plus beta 2 x2 plus plus error. And then this one, the x1 x2 are the predictors. And why is regression important anyway? It helps us to predict outcomes. It helps us to understand relationship between independent variables and the dependent variable. And it also helps us to measure the impact of each predictor. For us to understand this this better, let's take let's consider an example here. Now, given our regression model, our multiple regression model, this, our monthly revenue, our y here is our monthly revenue. X1 represents our food quality in the restaurant. X2 represents service quality in the restaurant. X3 represents customer satisfaction in the restaurant. So now, if food quality, service quality, and customer satisfaction does not exist, that means our revenue is likely to, our monthly revenue is likely to be, then we quote this value here. We quote this value here. And then this one here is the error we are likely to encounter. So our food, this X1 is food quality, X2 service quality, and X3 customer satisfaction. So what we do is, if there is a change in any of this one, how does it influence in the monthly revenue? So what we always use is we increase each and every one of them by one, and then see when we increase this one by one, what will be the effect on the monthly revenue. So when food is being increased by one, the beta 1 here will be the corresponding change in the monthly revenue. When food quality is increased by 1 unit, then the monthly revenue is likely to, if here is positive, it means it's likely to increase. Then you quote this value. If it is negative, that means monthly revenue is likely to decrease by this. And the same applies to service quality. If service quality is increased by 1 unit, or we added an additional service into the restaurant, what will be the corresponding monthly revenue? So the monthly revenue is likely to increase by, then you quote beta 2, since x2 and beta 2 remains at the same place. And the same thing we do for the other ones. To better understand regression, we need to understand these three measures: R square and adjusted R square. R here is the qualitative relationship the independent variable shared with the dependent variable. For example, the qualitative relationship food quality, service quality, and customer satisfaction shared with monthly revenue. And then the R square is just their contribution to the monthly revenue. So assuming our monthly revenue is $1,000, and then our R square is 0.60. That means we just multiply it by 100% and we'll get 60%. So that means 60% of the monthly revenue is from this and that. So that is to say, if we gain $1,000 at the end of the month, that means this, and it is 60%, that means these three items has contributed $600 to the 600, or it has $600 into this one, into the $1,000. So which means that if we take these ones out, the monthly revenue is likely to be $400. So that is basically what R square is about. So we say R square is the variation in the dependent variable explained by the independent variables. The problem with the R square is that when we keep increasing the predictors, these are the predictors, when we keep increasing, the R square keeps also increasing. And for that matter, some of the variables that we are increasing or we are adding into the model, they don't have significant impact, but R square will tell us that they have impact. So R square will keep increasing. So that is basically the problem with the R square. And mostly we don't usually use it when we are dealing with our research. We rather use the adjusted R square. The adjusted R square here addresses the problem of the R square by taking into consideration the values of only variables that has significant influence into the dependent variable. For example, if we add some other variables which doesn't have meaningful influence to the monthly revenue, that means adjusted R square will not add its value. So adjusted R square is just being specific. It takes into consideration only values that comes in to add additional value. But for the R square, if we add any other variable, it will increase. So that is basically what the adjusted R square is about. And that is why mostly we use adjusted R square in our research, because it tells us the specific information the predictors are contributing to the dependent variable. So now how do we report our, let's take an example of how we report our regression coefficient. Assuming marketing spend is one of the predictors, so we want to increase the marketing spend to see its influence on the monthly revenue. So, and then when we are increasing this one, we hold the other variables constant. We can't be increasing marketing spend and be increasing food quality, service quality at the same time. No. That is why whenever you are reporting, we say holding other variables constant. So if marketing spend increases by 1 unit, the model estimates that monthly revenue increases by X unit. The X there is the beta value that we are talking about. So if it is in dollars, then you indicate dollars. Holding other variables constant, that means when you are increasing this one, you don't have to move this one, you don't have to increase and you don't have to reduce them. That is basically what we see. So this particular part, holding other variables constant, is very necessary whenever you are reporting the regression model. And we have some assumptions we need to meet whenever we are dealing with this multiple linear regression. There should be linearity. That means the independent variable should be linearly related to the dependent variables. And so when we come here, y should be linearly related to x1, x2. So we don't have to get some to be x squared. No, they should be having power of 1. So all this one, the x values must all have power of 1. And then independent observations. So for example, if we record, if a customer comes and we record his information, or customer 1 comes and we record his information in the restaurant, the information we are recording from customer 1 in the restaurant shouldn't be dependent on the information we are going to report or record on customer 2, and that should not also be dependent on the information we are going to record on customer 3, in that order. So independency, observation should be independent. Homoscedasticity, the residual variance, so the variance of our residuals, the residuals here is just the error. So the variance of the errors should be constant. So it shouldn't just be varied too much, it should be approximately constant. And then normality of residuals, so we have to also check the normality. So the normality of residual should be it should be normally distributed. So, and if you don't understand the normality, please, you can watch my normality video. It's part of my videos in this channel. And then multicollinearity, predictors should not be highly related. So food quality should not be highly related to service quality. That is the multicollinearity. And when we run our analysis from SPSS, we get 3 main outputs. And the model summary, it shows the R square and then the adjusted R square, and I have already explained them. And the ANOVA test check the overall model significance, whether this model here, the model we have here, trying to use these items to measure this, whether it is significant. That is what the ANOVA is about. And then coefficient table shows each predictor's effects. So the coefficient table is just telling us the effect of this one, the effect of this one, so each and every one of them. So that is what their table is about. So now, if multicollinearity, we are going to do it on its own. So, but we have to understand what it is. Later, we would create a video on it. So do not worry. Before we finish regression, all these ones will be covered. So now, our multicollinearity is a statistical phenomenon which determines whether variables are highly correlated, predictors in predicting variables are highly correlated in the regression model. So the predictors should not be highly correlated. So this one is just trying to check if they are highly correlated. And if they are highly correlated, then that means there is a problem. So we have to do something about it. And how do we detect multicollinearity? We detect multicollinearity in 3 main formats. We use the correlation matrix, the tolerance, and the VIF. The correlation matrix here only tells us there is an existence of multicollinearity. And how do we do it? The value should fall between, the R value should fall between 0.75 to 0.99. That means there is existence of multicollinearity. And then the tolerance here is just telling us the unique information a predictor is contributing to the model. That means the information the predictor is contributing to the model, which other predictors does not contribute. For example, let's come to our model here. The information or the contribution of food quality into monthly revenue, which is not coming from here or there. So the unique information from this one, that is what we call the tolerance. So and the tolerance, that means that it shouldn't be small value, it should have a much unique information. So if the information is so small that it is less than 10% or less than 0.1, that means it has serious multicollinearity issue. So it's sharing big relationship with some other variables. And then we have to take action. For here, we can take an action. So I will show you how we deal with those actions. So that means the multicollinearity is serious. And then we also, another thing too we also use is the variance inflation factor. It shows whether the predictors are highly related to each other. And how do we do it? That one, we don't use the relationship, we don't use this one. We compare the VIF to 10. So if the VIF is less than or equal to 10, that means we can consider the data and work with. But if the VIF is more than 10, that means there is serious issue, or there is a multicollinearity issue, or serious multicollinearity issue. So what happens when we detect that multicollinearity is very high? How do we handle it? These are the solutions. Maybe if two variables are highly related, we remove one of them. That means they are likely to be having the same information. So we remove one of them so that the other one can uniquely add value to the model. So that is the first one. Remove highly correlated predictors. And then sometimes even if we did not remove them, if theory justify that the two variables should be included in your research, that means we can take average of the two. So we combine them to take the average. So that is also another way to address the multicollinearity issue. And then the third one is we increase the sample size. But this one is not always helpful. It only helps sometimes. So that one you can discuss with your supervisor to take an action. So basically these are the things you need to know about regression analysis. So when you are going to run your regression analysis, you need to understand all these things. So our next video is going to concentrate on using the SPSS to run the analysis, so that you see all these things I just explained practically. Please keep learning, or just follow, and then you understand it better. And please turn on your notifications so that you will not miss further important videos. If you have any question, you can reach out to me. Have a great time.